Hello, my name is William Garner, and this is my Homework 5 Question 1 video, just talking about my lane detection code. So, I actually have two different versions of this, one for each problem, and I'll kind of talk about why in a little bit. I kind of want to walk you through what I was doing exactly through each step of my process. So of course, first we have to grab the individual frame from the image using this command here. Additionally, that image is a little too big, so this is a part of what we did in class. We decided to snip the image just to make it a more reasonable size for the area we were working with. We then created a mask to kind of do something similar, but just to have like an area defined that we wanted to work with. So that's what the mask did. We overlaid that on top to make sure we had a very strict defined area. Next, we set some thresholds for color masking, and what this did was give us a range of colors that we were able to work with. And so here, these are the ranges I ended up with. If I had more time, this is what I would want to play around with a little more, just to make sure that I would be able to get a more accurate detection. And we blurred it with I used an 11 by 11 kernel size because that just worked the best for me. And then we had the edge thresholds. These turned out pretty well, I think. I'll show you in a second how those turned out, but of course I would like to play around with them a little more. And now we're getting to the kind of more complicated part of things. So this hue lines command, this function turned the lines that I got from my edge command, and it turned those into an array of points that are described by, they're actually in polar coordinates, so rho and theta. And so in my next command, which is when I'm actually forming the lines, I have to convert those eventually into the Cartesian coordinate system in order to plot them. But that's getting a little ahead. First, what I did was create an image, or an array, a zeros array, that was the same size and shape of our original image. And then I also had to make sure that it was a 3D matrix to allow for the BGR values to be set. One issue I was running into was I forgot to make it a 3D matrix and was having trouble. I couldn't figure out why my lines were turning out just white. And then I eventually realized. Anyways, I also create some arrays for the left side of the lane and also the right side of the lane, just so I can sort the lines that we create in order to figure out which one is which. So I first check and make sure that the array is not empty. I know it says check if array is empty. That's a mistyping on my part, but I want to make sure the array is not empty so that the rest of this code can go, because if it was empty, none of this would work. And then I go line by line. I check each line at a time, and it takes out the rho value and the theta values. And then through some just testing, I found that a theta of around 2 radians was the kind of the differentiating. That was kind of the threshold that worked for me. Just looking at the theta values that I printed the theta values, and that was that value from 0 to 2, and then 2 to 3. That was the cutoff for each. So then I put if theta is less than 2, that means that it's in the left lane. So I store those values, those rho value and theta values that it's looking at on that line. I store that in my left lane array. And then otherwise, if it's above 2, radians, then it stores in the right lane array. And then just in case some freak accident, I included an else command just so it doesn't freak out and stop working. So next I have two fairly similar if statements for the left and right lanes. The first thing I'm doing is taking the medians of all of those values. So I take it from the row values are one column and the theta are another. So I take each column's median and then label that left row and left theta. Next I just do pretty standard Cartesian from polar conversion, doing the cosine and sine of theta and then multiplying it by the row value. And then in order to create a line from these points, I used similar to how I did the x zeros, except this time I multiplied the a and b values, which I was using as a placeholder, by a number. I did the same over here, and this was mostly just a trial and error thing. One thing I would like to do is have it go based off of the code, like be specific to each, to not have to change it for each video, so that way this code could work more fluidly with different camera setups in different videos. So I create two different points, or two different sets of coordinates, one coordinates and two coordinates, so that way I can create a line based off that. And my left lines are blue, and then my right lines are green. And like I said, these are kind of just trial and error numbers that I came up with just by running the code a good bit. And then I saw after I'd finished that I didn't need to do an indicator, but I'll walk you through my process really quick anyways, or like the in-between part is what I mean by indicator. So I create another zero array, and then if there's a right lane and a left lane value, it creates a shape between the points that were generated above and here. So that way there's a shape between them, like in the shape of the lane. And then what I do is I use the add weighted command to overlay the indicator on top of the line image that I was generating up here. These cv2.line commands are working on the line image that started off as an empty array, and then changed to have the lane line. So I overlaid that by using a intensity of 0.5 to get it a little more transparent. And then the last thing I do here is another add weighted command, but this time I'm taking that final lane image with the lines and the lane shape in between and overlaying that on top of my snipped image. So after all that, it's going to look like this. Why it's not typing? Give me 1 second. Okay, sorry about that. I just had to get it back going, and this is the result. It starts off a little rough, as you can see, but after it figures itself out, it does work fairly well. Now we do have some blips here, and I would like to figure that out. I think what I would have to do is fine tune my thresholding values so that way it can create better lines from these. That I think that's the case and what I'd have to work on, but generally, especially the right side, holds up very well as the video goes. Now, like I said, I did a different method for the masking of the second video, and that was mostly because I had a lot of issues trying to set the thresholds for the mask and get good values. So I decided, instead of doing it with the HSV conversion, I converted everything to grayscale first, and that just gave me a much easier time grabbing those line indicators and just being able to use those. Again, in the beginning of this video, it kind of gets a little crazy, but that's because the light like blooms very quickly. And then the only other changes here are just some of the values for thresholdings I was messing around with, like the hue lines. I was trying to find a good number that might work for that, to make it work better. This ended up working decently for me. We can do this. Yeah, so the bloom really has a hard time with getting to work, but once it clears up, it's a lot slower here, but it works fairly well. Again, we have a little bit of just the left lane line not being recognized, but as you can see here with the mask and the edging, it seems to be good. I think I would just need to fine tune my hue lines, thresholdings, and everything after that just to make sure it works. Again, with switching lanes, it does not love that sudden change, and we have a couple more issues here. In the shadows, it doesn't love either. So if I had more time, I'd like to just play around with it a little more and fine tune my values. I didn't make a crazy amount of changes to the actual code besides what I added myself for the actual creating the lane lines, but yeah, I would just in the future, I think I would like to spend a little more time fine-tuning, and then I think that is all I would want to do. I'll want to change. There also is, I think, of course, with better hardware, you're going to get better results. Like with a better crisp, or better quality camera, maybe I could get more specific thresholds, but I didn't have the most specific thresholds anyways. But yeah, I don't really think too much on the hardware or software could have made this a crazy amount better than it is. Anyways, that is what I did for my question 1 of the homework, the lane detection. Thank you for listening.